Hey, it's Mrs. Weethy here, and we're going to start a unit on stoichiometry. So, stoichiometry involves mathematical relationships between reactants and products, and we're going to learn all kinds of things that are related to the stoichiometry. Okay, so these are the curriculum standards, and what I want you to do is to pause the video and write down these standards on the first page of your unit stoichiometry in your chill. Alright, now that you've done that, let's continue with lesson 1, which is an introduction to stoichiometry, and from the learning goal you will see that you will be able to write mole ratios from balanced chemical equations. First of all, what is stoichiometry? By definition, stoichiometry is the study of quantitative relationships, quantitative meaning numbers, between the amounts of reactants used and products formed by a chemical reaction. It's all based on the law of conservation of mass, which we have studied when we were balancing chemical equations. So let's take a look at this reaction. The law of conservation of mass says that the mass of the reactants has to be equal to the mass of the products. But if you notice, you have those coefficients in front of each one of the reactants and products, which shows us that if we add up the coefficients, they're not equal on both sides. However, because you have 7 on one side, 2 on the other. Alright, if we take a look at our coefficients. But if you add up the formula masses of each substance and added up the mass of the reactants and products, you would see that the masses on both sides of the equation are the same. So let's take a look at that. 4 irons would be equal to 223.4 grams. Okay, and where do we get that from? The mass of iron on the periodic table times the coefficient of 4 gives us that number. 3 oxygens is 96.00 grams, and 2 iron 3 oxides is 319.4. So add those up. The mass of the reactants is equal to the mass of the products, which satisfies the law of conservation of mass. So how are we going to use this? What does that balanced equation mean? We have to focus on those coefficients. Those coefficients represent the ratios of the reactants and products. Just like when you have the subscripts in the chemical reaction, that represents a ratio of the number of atoms of each element that make up that compound. Well, these coefficients also are the ratios of the reactants and products that are interacting in the chemical reaction. And we can read this in 2 different ways, in terms of particles or in terms of moles. So, in terms of particles, we have 2 atoms of aluminum react with 3 molecules of bromine to form 2 formula units of aluminum bromide. In terms of moles, we can read this as 2 moles of aluminum reacts with 3 moles of bromine to give us 2 moles of aluminum bromide. So how do scientists use these? We use the ratio of moles to quantify or measure the amounts of reactants and products that interact in a chemical reaction. Why do we use moles? Well, one thing we can't do with moles or atoms or molecules is we can't measure them. We can only measure the mass of the substances or the volumes of the substances that are reacting and being produced. But one thing that all substances have in common is a formula mass, which is the mass in grams of 1 mole of that substance. So that's the common factor between all substances, is its formula mass. If you know the formula mass of a substance, you can convert from moles to grams or grams to moles. What we want is we want to represent every substance in the amount of moles, no matter what you're given. If you're given grams, if you're given liters, you want to convert to the number of moles. And then using the mole ratio, we can convert the moles of one substance into the moles of another substance. Okay, so how do all the moles relate to one another? We call that the mole ratio, which is the ratio of moles of 2 substances in a chemical reaction. And that's the key thing. At any time, you will only be working with 2 moles. And the mole ratio serves as a conversion factor. Now, when we say a ratio, we're set the ratio up as fractions. So let's take a look at 2 substances and set up the coefficients, the number of moles, as a fraction. So we have 2 moles of aluminum over 3 moles of bromine. Okay, and it's inverse. So these are 2 possible mole ratios we have from this chemical reaction. We can have 2 moles of aluminum bromide over 3 moles of bromine, and its inverse, 2 more. And then lastly, we can have a relationship between 2 moles of aluminum bromide over 2 moles of aluminum, and its inverse. And here we have 6 possible mole ratios. The question is, in a problem, which one do you use? And that is dependent on the 2 substances that you're studying, which one is the given, which one's the unknown. And when we set up the conversion factor, as in the past, when you do a conversion problem, you always put the unknown over the given. Now, let's say that the unknown is bromine and the given is aluminum bromide. Out of these 6 mole ratios, which one would you use? And this is the one that I would choose because I said bromine is the unknown and aluminum bromide is the given. So that would be the mole ratio, their conversion factor, that I would use in the problem. Now, I know that this doesn't make sense right now, but when we start doing the problems, it will all start coming together for us. Okay, and so that was the end of lesson 1. This is Mrs. Weethy. So long for now.